So hello friends, this is fourth lecture of data science using Python series. In this series, I will cover the topic of data preparation phase to model the data. So first of all, we understand data preparation. Why data preparation is important? Before we can build a model, we can need to prepare the data. Without proper data preparation, our model may face issues such as overfitting and underfitting. So understand this, what is overfitting and underfitting issue? Overfitting means where the model learns too much, where the model learns too much details, too many details from the training data and performs poorly on a new and unseen data. Means that when we try on unseen data, our model is failed. Next is underfitting. Underfitting, where the model fails to capture the underlying patterns in the data and perform poorly on both the training and testing data. So this condition is underfitting. So here, to remove this overfitting and underfitting issue, we need to prepare our data. So how can prepare our data? First of all, I explain with example. Example of data preparation. Here, loan approval prediction. So what I do here, let's consider an example where we are predicting loan approval based on customer data. We have information like customers income, education and credit score. Our goal is to predict whether a loan will be approved or not. So step 1 here, partitioning the data. We can we participate our data into terms: training data set and testing data set. Next, partitioning the data. We use here pandas and skitler library model. Here, xtrain, bytrain, xtext, bytest. So I explain this with the code here. So this is the code of our data preparation phase to model the data. Here in this code, data preparation phase to model the data, how to partition the data using Python. So first of all, we import a library, import pandas at pd, from sklearn.model selection, import train test split. We can import this, and here bank additional.csv file that contain all type of data here, here. Next, if by in bank dot columns and response not in bank dot column, here bank is equal to bank dot rename, columns equal to by response. Partitioning the data, here bank trend, bank test. So here bank test split method used for partitioning the data. Here, next, check the shapes of the data set. So here I check the shapes of the data set here: bank.shape, bank trend.shape, bank test.shape. So how can understand it is correct or not? So we understand this, that if 1000x is a number, where x is a number of columns of our data set, so bank trend.shape data is contained 750 dot x. Means here 750 columns are 715 data columns are used to train the data, and for testing the data we use 250 total records. So here 75 plus 250 is equal to 100. That means our model is evaluate the data correctly. Here original data set shape 10 comma 13 and training data set 7 comma 13. Testing data set 3 comma 13. So it is equivalent to 7 plus 3 10. That is original data set. So this is the process of our partitioning the data here. Next is how to balance the training data set using Python. So for balancing the training data set, we understand need of balancing, where we use the balancing of the training data sets, where we need to balance the training data set. So sometimes we can see that we create a biased model that seems accurate but do not work well for the less common category. So here understand with this example here. Uh, so purpose of balancing here to improve the model performance on minority classes. Balancing the training data sets is essential by increasing the representation of the minority classes. So understand this using an example. Here is an example. If only 1,000 out of 1 lakh credit card transactions are fraudulent, a model that predicts non-fraudulent for every transaction would achieve 99% accuracy. Means here, if 1 lakh credit card transactions are here and 1,000 are fraudulent. So in this case, if we predict on non-fraudulent transaction, so our model would achieve 99% accuracy here. But it would not be useful since it fails to identify any fraudulent transaction. Means here, if any fraudulent transaction occur here, so it is not read properly, so it is inaccurate in this case. So to remove this, we need to resampling. So resampling involves randomly selection records from the dataset with replacement to create a more balanced distribution of classes. For instance, if we want to increase the representation of fraudulent transaction from 1% to 25%, in our training data set, we can add resampled record of the fraudulent classes. So this is the process. Example calculation. Understand this. Let's suppose total transaction is 1 lakh and fraudulent transaction in 1,000. This is a 1% of our 1 lakh records. Okay. So we want to increase 25% fraudulent transaction here. So we calculate 0.25 into new total transaction. Calculated target total transaction action is equal to 1,32,000 here. So targeted fraudulent transaction here 0.25 into 1,32,000 is equivalent to 33,000. So after the minus we can get 32,000. So current fraudulent transaction is 1,000 and desired 25% of 1,32,000. So this is 33,000. So additional fraudulent record we need to add the training data set is 32,000. So this is the process of resampling. Now we understand with the code of resampling. So this is a code of resampling here. Resampling here, the code is for step 3, display the initial count of response variable in the training data set. Because we need to response variable here, so we write this dot counts. For minority classes, identify yes for the fraudulent cases and non-fraudulent cases. So here we can use this code. You can see this code. Target proportional 0.3, total records, length of bank transaction. Calculate how many additional yes response are needed, because in the code we need 32,000 yes. 32,000 yes cases we need here. So we calculate the, for resampling we use this bank trend.log method used for resampling. Response yes. Calculate additional record needed with the safety check. Additional record needed max 0 targeted yes count minus minority class count. So additional records needed is equal to minimum and maximum we calculate here. Additional yes records needed, adjusted additional records needed. So in this code we will calculate our 32,000 cases what the need of increasing. So this is the output here. This is the output. Initial class distribution in training data set is no 4, yes 3. So name count d type in 64. Additional here no 4, yes 3 count rebalancing training data set 7, 13. So this is the need of our resampling. After the resampling, our model is accurately trained. Next is CART tree. Next is CART tree. So what is classification in regression tree? First we understand this terminology. Classification in regression tree is a type of decision tree. It based on a binary search tree. It is the basically concept use binary tree. Here we have two nodes, two branches here. By splitting data into two subsets using Gini index for classification. So we understand within an example, we solve our example. So this is an example of classification and regression tree here. So in this case, we have a IBM Intelligent Miner Gini Index challenge here, Gini Index question here. So in this question, our we have to predict loan approval. So this is the data set: own home, married, gender, employee, credit rating, and risk classes. So here we have to create a decision tree for this columns. So here number of example, first of all we calculate number of example, means number of rows. S is equal to 10. Number of classes, here we need to predict 3 classes. Risk classes prediction is A, B and C here. So 3 classes. Frequency of class A 1, 2, 3. So frequency of class is 3, B 3 and C 4. So using an index we need to calculate using this formula. G is equal to 1 minus 3 by 10. 3 is our risk classes calculation, and number of example, total number of rows is 10. So we need to calculate 1 minus 3 by 10 square minus 3 by 10 square minus 4 by 10 square. So Z Gini index is equal to 0.66. So this is a calculation of our Gini index first. Next we calculate for each column, need to each column. So here own homes for value by, there are 5 applicants who own homes. There are classes. So for by, so own home by risk class is by, for by risk class A is B calculate 1 here. Risk class C for by, C is 1 2 3 4, and A is 1 and 2 and B is 1 and 2 for by. So for by we need to calculate this type of classes. For A is equal to 2, B is equal to 1 and C is equal to. For applying the Gini index formula here, 1 minus 1.5 minus 2.5 minus 2.5 equivalent to 0.64. So total value of Gini index here we calculate 0.5 G of by plus G of N. We calculate Gini index prediction using for yes and no. So we calculate this for yes and no prediction for this type, such as own homes. We calculate each and every column here for merit, for gender, for employee, for credit rating, and after this we evaluate this type of table. So attribute own home, married, gender, employee, credit rating here. So Gini index before split 0.6 is Gini index after split is, and gain is here. So here 0.302 is a highest gain in case of gender. In case of gender Gini index after split is 0.358. So this is a higher, mostly higher in all. So first we create a node using gender. Next node creation we calculate this again and again. So this is our root node of gender. So after this we calculate all nodes, such type of listing. Next is we understand with the example using code here. So this is a code of our classification and regression tree. Here we import the library, pandas library. This is our data set: home, home, married, gender, employee, credit rating, and risk classes here. Convert the data into data frame. We convert this into data frame, and we calculate here risk classes So for calculating decision tree class, we use the method of decision tree classifier and use the criterion Gini for, because we need to classify using Gini index. So we need to calculate next for CART tree, CART model, we use the method of decision tree classifier using the criterion Gini. Why Gini? Because we need to calculate with the Gini index. Next is card.model.fit, because it is a it create a classification and regression model here. Next is visualization the decision tree, such type of tree we can create. With the example I explained, first root node is our gender, because its Gini is 0.6 is sample 10, value is equal to 334, class C. In this column means if if we see the gender for female here, so if the gender is female, we directly predict the class C for loan approval here. So it is the importance of classification and regression tree. There we need there we calculate such type of predictions. Then if female is less than equal to 0.5, gender female is less than equal to 0.5, such condition is true, then our home, we calculate our home, then the column of married we check. So this is our classification and regression tree for this data set. So this is a classification and regression tree for this data set. Next is using 5.0 decision tree. So what is 5.0 decision tree? It is similar like our classification and regression tree, but some dissimilarity here, only one and two dissimilarity. So I explain here. We'll see 5.0 decision tree using Python here. It is similar as a decision tree, but maximum label of tree nodes are 5. So where decision splits are made at each level, it controls the complexity of the tree, because here only 5 labels are we create only. It's deep to prevent it from growing too large or overfitting the training data sets. So this is our C5.0 decision tree. So I explained with the code how to build C5.0 decision tree. So this is our code. So exploring the tree, we import the libraries such as classification and regression tree. This is our data set, own, home, married, gender, that I explained with the example. Next is convert the data frame into data frame. We convert this into data frame. We create dummies means here columns, and x and y is a x is a features and y is a target. So our target is to predict the risk classes. So y is equal to df risk classes, because we need to calculate risk classes here. Next is initialization the decision tree classifier. So criterion using entropy. So this is first dissimilarity using our in our CART decision tree and our C5.0 decision tree. You can see here we use the criterion Gini, but here we use criterion is entropy. Now in this series, I will not explain what is entropy. You can explore with ChatGPT and other. So now this is the criterion of our entropy. Maximum leaf node is equal to 5, because in this C5.0 tree, we only create the node 5. Prediction. Here we use model.predict function. Prediction for prediction, plt dot figure size, we can set the figure size of our tree 16 10. Exploring graph wise, this is the method of exporting the decision tree in the dot file. After this we get the c50 dot dash tree dot file our output file here. So this is our classification and regression tree. You can see here, you can see here, you can see here. So this is our classification. This is our classification and regression. Sorry, this is our C5.0 decision tree. It is similar as our classification and regression tree. You can see here output. This is our output, but here it is used in entropy. Next is importing necessary. So this is the last topic of this video, how to build a random forest here. So how to build a random forest, I will explain here. What is random forest? Random forest is an extension of decision tree. You can understand, you need to understand what is random forest. Random forest is nothing, only on an extension of decision tree. While the decision tree creates a single tree based on the data set, random forest uses multiple decision tree for predictions. Here we need multiple decision tree for prediction. We not need only one tree here, because sometimes our one tree is not accurately answer. Our one tree is not create perfectly, and our one tree is not predict sometimes right prediction, not gives right prediction. So here our we use the method of random forest. Random forest is a method because random forest is a method. Here multiple decision tree, and multiple decision tree based we create a random forest. So this is used for ensemble learning. Ensemble learning means combining multiple models to improve performance of one model. So in this case, we what is the aim of creating random forest? So our aim is to create a random forest is discard the overfitting issue, because we faces overfitting issues when we use only one decision tree. And okay, so we use random forest. So how can create so this is a concept of random forest. I will explain in details. Applications. Random forest can be used for both classification and regression tasks, but it tends to provide more accurate result in classification problems. So random forest is used for classification and regression, both type of tasks, but much better is for classification tasks. This is the concept of a random forest. So here we want to predict the email is spam or not spam. So this is the data. Here 300 is our data emails. In this emails we create three tree. First tree 100, 100, 100. 100 data set, we create a tree, three tree, and this is the output of spam and ham not spam. So majority voting we calculate here, two tree sets is spam. So final class we predict is spam. Concept here to understand is this, need to understand this. If we create a model and the model create using a one decision tree, so it is sometimes gives spam and sometimes gives spam not spam. So this is the inaccurate and this is a not correct. So for correcting this thing, we use a random forest. I think you understand the concept here. Next, how to create a random forest with code. So this is a code of creating random forest. I will explain you here. This is a code. In this code, we import the libraries such as pandas, sklearn, and matplotlib for creating the plots. Make classification and sample is equal to 100. We create first of all three trees here. So this is first xtrain, textrain, xtest, bytrain, this type of things be done here. Here we create our three trees. After this accurate square is accurate square by test by prediction plt.figure. This is the visualization of our random forest tree. Using matplotlib library, we create the output data set here, output chart here. So we can estimate this. So I explain this here. This is a output. Here you can see recall F1 score, support, accuracy, weighted score, random forest tree visualization, feature 1, feature 2, feature 5. This type of random forest we create here. So this is the completion of this series. I explained in this series